15 meters per second at an angle of 30 degrees to the horizontal from ground level. This gives it an initial vertical velocity of 7.5 meters per second and an initial horizontal velocity of 13 meters per second. So the setup here is a little bit awkward because we've not talked about resolving vectors yet. This always happens. We have to do one of these two things first, and whichever we choose, it makes it slightly awkward. So eventually we'll get to how we turn the 15 meters per second and the 30 into these two values of speed. But for the time being, we're going to be given them. So to find its time of flight, all that matters is what happens in the vertical direction. In the vertical direction, we know its initial velocity is upwards and it has a speed of 7.5 meters per second. We know the acceleration is equal to minus 9.81 meters per second squared. Let's try and stick to the right way of writing the units. And we know that the total displacement in this particular case in the vertical direction is 0. That's because it's launched and lands at the same height. So we want to find the time of flight. We're going to use the equation S equals ut plus half at squared. This then, sorry, we can do some rearranging of, we're going to have 0 is equal to ut plus half at squared. And once we get this, the easiest thing to do is divide through by t. That's because 0 divided by t is still 0, but it gets us rid of the t squared and one of the t's. So I'm going to cross out a t here and cross out the squared over here. So we could say that again, this means u is equal to minus a half at, or that t is equal to 2u over minus a. So that is 2 times 7.5 divided by plus 9.81. Is 1.53. We're doing it to two significant figures again, so 1.5 seconds. The range, the horizontal distance it travels. So now we're looking in this direction. We know that the time of flight is the same for both, so 1.5 seconds. And that the initial speed in this direction is 13 meters per second. That the acceleration is equal to 0 meters per second squared. In the horizontal direction, there's no force acting, so no acceleration. S is equal to ut plus half at squared, but there is no a. So S is equal to 13 multiplied by 1.5. That is, what's half of 13? 6.5, so 19.5. But we're only going to do it to two significant figures, so we round up to 20 meters. C, its maximum height. So a couple of different approaches to doing this. One is to say that the maximum height occurs at half the time. Alternatively, we could look for the displacement when the final velocity is equal to 0. So this is kind of the way I prefer doing it, partly because we might be sick of using the same Suvat equation all the time. So we're going to say we want a final velocity equal to 0, an initial velocity equal to 7.5 meters per second, and an acceleration equal to minus 9.81 meters per second squared. We want to find the displacement, so we're going to use v squared is equal to u squared plus 2as. Rearranging, we get S is equal to V squared minus U squared over 2A. In this particular case, then V squared is 0, so we've got minus 7.5 squared divided by 2 times 9.81 minus 9.81. Which is 2.86, so 2.9 meters